So, something pretty wild just happened in the world of AI. A brand new benchmark dropped, and the results? Well, they're not just surprising, they're downright shocking. The most advanced AI models on the planet, the ones we hear about every day, were completely stumped by a test that humans find pretty easy. Let's dig into why. All right, first things first, we need a baseline to understand just how wild these results are. On this new test, the human score is set at a perfect 100%. Easy enough, right? Now, get ready for this. On the left, you see us, humans, at 100%. And on the right, the most powerful AIs we have, GPT, Gemini, they're scoring less than 0.5%. I mean, look at that. They barely even make a dent on the chart. It's basically a flat line. And that brings us to the big mystery here. How is it possible that these incredible models, the ones that can write code, create amazing art, even ace medical exams, are failing so badly at a test that, for a human, is actually kind of fun? What is this test even measuring? Okay, so the test is called the Abstraction and Reasoning Corpus, or ARC-AGI-3 for short. And here's the key. This is not a pop quiz. It's not designed to measure what an AI already knows. It's built to measure something way more fundamental, its ability to learn on the fly. The test is really built around these two types of intelligence. Think of crystallized intelligence as your own personal library of facts, everything you've ever learned. But fluid intelligence, that's how quickly and efficiently you can learn something totally new. Our current AIs are absolute masters of crystallized intelligence. They're giant libraries. But this ARC test, it's all about fluid intelligence. Now, this isn't the first ARC test. The benchmark has been evolving for a few years. It actually started out with static puzzles, kind of like a standard IQ test. But this latest version, ARC-AGI-3, took a massive, radical leap. It moved away from just static images and into fully interactive worlds. And this chart right here really shows you what a huge shift that is. Instead of just passively looking at a problem and predicting an output, the AI now has to get its hands dirty and actively explore a little world. The goal isn't just to figure out some rule that's handed to it, it's to discover the goal itself by messing around and seeing what happens. So let me put it another way. The old tests were kind of like showing an AI a few solved math problems and then asking it to solve a new one. This new test, it's like dropping the AI into a video game it's never seen before with no instructions and just saying, good luck, figure it out. It's not about what you know, it's about how you learn. And to make things even harder, the scoring system is absolutely brutal. It's not enough to just solve the puzzle. You have to solve it efficiently. The main metric is called relative human action efficiency, and it directly compares the number of moves the AI makes to the number of moves a human makes. And this scoring creates a massive penalty for messing around. So let's say a human solves a puzzle in 10 actions. If an AI takes just one extra action, 11 instead of 10, its score tanks all the way down to 82%. And if it tries to brute force it and takes 100 actions, the score completely collapses to just 1%. Any inefficiency gets punished quadratically. So you see, the test is specifically designed to reward that spark of human-like insight and to totally crush any attempt at brute force guessing. You don't just have to find the answer, you have to find it with elegance and efficiency, just like a person would. As you can imagine, this radical new test and these devastatingly low scores have kicked up a huge debate in the AI community. People are asking, is this really a fair way to measure machine intelligence, or are the goalposts being moved in a way that's just unfair? At the heart of the debate is this idea of a harness, which is basically extra code that helps the AI see, remember, and interact with the game. One side says, hey, testing a language model without a harness is like asking a human brain to solve a puzzle without eyes or hands. It's just not fair. But the other side argues that the true intelligence has to come from the model itself, not from a bunch of clever code that a human wrote to help it out. The creators of the test, the Art Prize Foundation, have a very clear and pretty powerful take on this. They basically say, look, if a bit of human-designed code can take a score from near zero all the way to 36%, then you're not really measuring the AI's intelligence anymore, are you? You're measuring the intelligence of the human who designed the code. And we actually have a perfect real-world example of this. A company called Symbolica used its own custom harness and claimed they got a score of 36%. I mean, a gigantic leap from the raw models. They even solved 7 of the 25 games. But because they used that harness, their score isn't on the official leaderboard, which really just highlights the core of this whole debate. When you put it all together, what ARC-AGI-3 has really done is shine a massive spotlight on a fundamental gap in AI development. For the last decade, the race has been all about scaling up crystallized knowledge, just making the libraries bigger and bigger by feeding models more data. This test shows that this approach has almost completely ignored the other side of the coin, developing fluid, efficient, human-style learning. Which brings us right back to this powerful definition of intelligence from François Chollet, the creator of the whole test. It's not about what you know. It's about the efficiency with which an agent can acquire new skills in unfamiliar situations. And if you use that as your measuring stick, today's AIs, for all their incredible knowledge, just aren't there yet. And that really leaves us with a huge, thought-provoking question. The results from this test are forcing the entire field of AI to stop and ask, as we push toward true artificial general intelligence, what's the right path forward? Should we keep building bigger and bigger digital libraries? Or do we need to focus on designing something fundamentally new, a better way to learn?